So good morning children. In the last period we took one example for limits and we have seen as x approaches some number, f of x approaches some other number. So we say that the limit value is that number like that. So we'll take one more example. For now we can just take down this definition. Learn this definition. These are not so important. But this definition you learn. F of x is a real number defined in the deleted neighborhood of a. That means the function need not be defined at exactly at a, but it should be defined on the left side of a and also on the right side of a. Then the limit extending to a of f of x is L whenever mod f of x minus L is less than epsilon and mod x minus a is less than delta. So this part you learn as the definition. So f of x should be defined in the deleted neighborhood of a. Now for left hand limit we write a minus, and for right hand limit we will write a plus, a minus, a plus. So these are the symbols. Sometimes we also write as limit extending to a minus 0. Like this also we write a minus 0 for left hand limit and a plus 0 for right hand limit. These are some symbols that are used in left hand limit and right hand limit. Okay, when these left hand limit and right hand limits both are equal, then only, and they are equal to some L, then only we say that the limit extending to a of f of x is equal to L. This is the important theorem. So in some problems we find left hand limit, we find right hand limit, they will not be equal. So when they are not equal, we say that the limit does not exist. So the limit of this function is equal to L only when the left hand limit is equal to the right hand limit. So you can understand when we do the problems. Now this definition we use in the problems for finding the left hand limit and the left hand limit like this and right hand limit like this. So limit extending to a plus of f of x is limit h tending to 0 of f of a plus h. That means you will just increase x value by a small number. H greater than 0 is like epsilon delta like that. It is a very small number. So f of a plus h, and then we'll find the limit. Here it is for left hand limit, it is f of a minus h. It is f of a minus h. Now we'll learn some properties of these limits. That is, suppose that you have some function f of x and g of x. F of x and g of x are two functions defined in the deleted neighborhood of a. Then, and suppose that limit extending to a of f of x is L and limit extending to a of g of x is equal to m. Then you can write the limits like this. So suppose that let f of x and g of x be two functions defined in the deleted neighborhood of a. Be two functions defined in the deleted neighborhood of a. And then suppose that limit extending to a of f of x is equal to L, and then limit extending to a of g of x is equal to m. Then you have these properties. Then limit extending to a of f of x plus g of x. F of x plus g of x I can write as limit extending to a of f of x plus limit extending to a of g of x. So that is equal to L plus m. It is equal to L plus m. So I can write the limit separately for both the functions and then find the limit. Okay, this is first one. Now second one is limit extending to a of f of g of x. Fg of x I can write as fg of x means f of x into g of x. F of x into g of x. I can write as limit extending to a of f of x into limit extending to a of g of x. So that is equal to L into m. Next, suppose you have limit extending to a of f of x by g of x, where the this limit m is not equal to 0. So I can write this as limit x tending to a of f of x by limit x tending to a of g of x. So I can write the limit for the numerator separately and denominator separately. I can write the limits like this. Limit f by g. Next, suppose that I have this function limit x tending to a of, suppose I have some 3 into f of x, some number k into f of x. Then I can write this as this number outside and write limit x tending to a of f of x. So that is equal to 3 into L. So in general, if it is any k number, k here, I can write k outside and write the limit as k into L, where k is a real number. So when it is the sum of two functions, you can write the limit separately. When it is the product, find the limit of first function into the limit of second function. When it is the quotient of two functions like this, find the limit of numerator and the limit of denominator and write the value. These are some of the properties, and one more property is limit x tending to a of some mod f of x, mod of f of x. So suppose it is like this, then I can write it as modulus of limit x tending to a of f of x. So I can write the modulus outside the limit. So these are some of the properties that we need in solving the problems. Okay. So addition, subtract, multiplication, subtraction again same, L minus M like that. Multiplication, division, and then okay, next we have one theorem called as sandwich theorem. So this is again very important for 2 marks. You may be asked to write the definition. We will be doing 1 or 2 problems based on this theorem. It says like this. Suppose that f of x is less than or equal to g of x is less than or equal to h of x, where x is the common element in all the 3 functions like that. I'll write the definition now. So f, g, h are 3 functions. Now suppose that limit x tending to a of f of x is equal to limit x tending to a of h of x. If the limits of first one and the last one are same, then this implies that is equal to some L, is equal to some number L. Then this will imply that limit x tending to a of the middle function g of x is also equal to L. This is the statement of the theorem. So the it is called as sandwich theorem. WICH, sandwich theorem. So learn the statement. Suppose that E is a subset of R and then F, G, H are 3 functions from one set. It is a real function. You can say that F, G, H are real functions, and suppose that A belongs to R. A is a real number such that A minus R, it is in the deleted neighborhood. So A minus R, A plus R, A minus R, A plus R, deleted neighborhood you have learned now, minus A. So this set intersection E is non-empty set. This intersection E is non-empty. It should not, if it is an empty set, you cannot define. No? So it should be the deleted neighborhood of A. This is nothing but the deleted neighborhood of A. That is non-empty for all A are greater than 0. Then, and suppose that if f of x is less than or equal to g of x on for all A in E, and then x not equal to A, because it is in the deleted neighborhood, and then suppose that these two limits are equal, then limit x tending to A of g of x is equal to L. This is called as the sandwich theorem. So you can just learn at least this part. You can just say f, g, h are 3 functions defined in the deleted. You can write in words. F, g, h are 3 real functions defined in the deleted neighborhood of A. F, G, H are 3 functions defined in the deleted neighborhood of A. if, and then you can just write this. This is the sandwich theorem. Now we'll do the problems. Problems wise, it is very easy chapter. You can easily do the problems once you get the method. So exercise, see, all these problems are like compute or find or evaluate. So all questions have this in common: evaluate, limits. So first problem, this is in exercise 8A. I'm including examples also. So one or two problems we'll do. One first problem, suppose I have limit extending to 1 of x square plus 2x plus 3. So you will just substitute 1. So we'll not be using any delta neighborhood, deleted neighborhood, all that. So we just substitute x is equal to 1 in this. So it is 1 square plus 2 into 1 plus 3. That's all. 3, 4, 5, 6. 6 is the answer. So like this we do. Okay. Next problem. Suppose it is limit x tending to 1 of 2x plus 1 by 3x square minus 4x plus 5. First substitute. Put x is equal to 1. So it is 2 into 1 plus 1 by 3 into 1 square minus 4 into 1 plus 5. So here what you should understand, note here is, when you are substituting the limit as 1 here, you should not write limit again. So when you are substituting, you will not write limit. You will just write the value. So it is equal to some 3 by 4. That's all. 3 by 4. That is the answer. Now suppose that you have a function like this. Limit x tending to 2 of 2 by x plus 1 minus 3 by x. Suppose you have like this. Okay. Now, then you just substitute 2 here. So it is 2 by 2 plus 1 minus 3 by 2. So that is 2 by 3 minus 3 by 2. Simplify. 4 minus 9 by 6. That is minus 5 by 6. That is the answer. That's all. So these are very simple problems. Now we'll do another problem. Limit x tending to 3 of x square minus 9 by x cube minus 6x square plus 9x plus 1. Now first I'll substitute 3 in this. Then I'll get 3 square. 9 minus 9, 0. Now we should see whether it is any indeterminate form. Suppose I substitute 3 here. 3 is 9, 27. So it is 27. Okay, 9 minus 3 square. It is actually 3 square minus 9 by 3 cube minus 6 into 3 square plus 9 into 3 plus 1. So it is equal to 9 minus 9, 0 by, this is 9, 27. So 27 minus, it is 54 plus 27 plus 1. So it is 0 by 1. As I said, 0 by 1 is 0. So the answer is 0. So like this you have to do. If it is indeterminate, like 0 by 0 form, then you have to use some other method and find the limit. So all these problems have compute or evaluate. So we evaluated and we got the limit value as 0, like this. Okay, now we'll do this problem. Next, fifth problem. So how many we did? 1, 2, 3, 4. And this is fifth problem. Okay, fifth problem. Limit x tending to 1. Limit x tending to 1 of x minus 1 by x square minus x minus 1 by x cube minus 3x square plus x. So if you just observe, when you put x as 1, this is 1 minus 1, 0. And this is also 1 minus 1, 0. So it is in the 0 by 0 form. So what you have to do is, when you get 0 by 0, it means that x minus 1 is a factor. When you observe here, it is, you can take x common, x into x minus 1 and you can cancel x minus 1. Now that the indeterminate form will be eliminated. So x minus 1 gets cancelled. So it is limit x tending to 1 of 1 by x minus 1 by x cube minus 3x square plus x. So now substitute 1. Then it is 1 by 1 minus 1 by 1 cube minus 3 into 1 square plus 1. So that is 1 minus 1 by minus 1. So that is 1 plus 1, that is 2. So here you must observe. See, the steps are very important. Where to write the limit, where not to write the limit is very important. So first we substituted orally. Always substitute the limit orally. If it is any indeterminate, then you have to simplify. If it is not indeterminate, then you can directly substitute and write the answer like in earlier problems. Now here when I substituted 1, we observed that it is 0 by 0 form. First term itself is 0 by 0 form. That is not indeterminate. But still, on the whole, it is indeterminate. So when you are substituting x as 1, it is 0 means x minus 1 is a factor of it. So that point you should observe and then see that take out that factor, cancel, and then substitute. You get like this. So here you are not substituting the limit. You are simplifying the inner function. Inside function you are simplifying. So this limit will be there. When you substitute this 1, you should not write limit. When you are substituting, in that step itself, you should not write the limit x tending to 1. It is already substituted. Now after simplification and all, you will write without writing this limit. So till where you are not substituting, this will be there in all the steps. Once you substitute, that should not be there. That is very important. Okay. Next problem. Next, sixth problem. Limit x tending to 3. Limit x tending to 3 of x to the power 4 minus 81 by 2x square minus 5x minus 3. Now when I substitute, you can see when I substitute limit as 3 here, this is 3 power 4, 81 minus 81. And here this is 3 3s 9 2s 18. 18 minus 15 minus 3, that is 0. So it is in the 0 by 0 form. So orally you can just substitute and find out whether it is in the 0 by 0 form or not. So here it is in 0 by 0 form, indeterminate form. That means you have to simplify. How to simplify? X tending to 3. So this I'll do it separately. X to the power 4 minus 81 can be written as x square whole square minus 9 square. So this is like a square minus b square. So a plus b into a minus b. A plus b into a minus b. This anyhow we cannot split. X square plus 9 into this you write as x square minus 3 square. Again it is in the form a square minus b square. So a plus b into a minus b. X plus 3 into x minus 3. So these are the factors. You cannot further split. Now in the same way, when you take 2x square minus 5x minus 3, you have seen when you are putting x as 3, it is becoming 0. So that means x minus 3 is a factor. X minus 3 into, you can think of the other factor. So 2x you will get and then plus 1. You can see it is 2x. Yes. So now write the factors. So this is x square plus 9 into x plus 3 into x minus 3 by x minus 3 into 2x plus 1. X minus 3 into 2x plus 1. Now you can cancel 2x minus 3, and when you substitute, it is not becoming 0. So it is 3 square plus 9 into 3 plus 3 by 2 into 3 plus 1. You are substituting, so you are not writing this limit. So 9 plus 9, 18. 18 into 6 by 6 plus 1, 7. So it is equal to 108 by 7. This is the answer. So like this you have to find the limits. It is very simple. So here when we are getting indeterminate form 0 by 0, one method that we used here is factorization. We found the factors, cancel the common factor like that, and then we simplified. So factorization is one method to find the limit when it is in the indeterminate form. Now we'll see another method to find the limit when it is again in the indeterminate form. Okay, next problem. This is very important problem. If f of x is equal to minus root of 25 minus x square, then find limit x tending to 1 of f of x, limit x tending to 1 of f of x minus f of 1 by x minus 1. So this problem is very important. F of x. So now the solution is, we'll take that f of x minus f of 1 by x minus 1. F of x, so we'll write limit x tending to 1 of this. So what is f of x? F of x is minus root of 25 minus x square minus f of 1 means in this you substitute 1. X as 1. F of 1. X is 1. So this is minus, I'll write like this, minus root of 25 minus 1 square. 25 minus 1 square by x minus 1. So I should write is equal to limit x tending to 1 of all this. So it is equal to limit x tending to 1 of, this is minus root 25 minus x square minus of minus plus root 24 by x minus 1. Now if I substitute 1, I'll get 0 here, root 24, so 0 by 0 form. So it is indeterminate form. So what should be done? Here can you take any factors like in earlier problem? No. So because you have roots here, you must rationalize. So what is the rationalizing factor? It is actually numerator. Actually I can write as root 24 minus root of 25 minus x square by x minus 1. So what is the rationalizing factor for this? It is like a minus b. So I should multiply by a plus b. So root of 25 minus x square by root 24 into root 24 plus root of 25 minus x square. So like this you have to do. So now this is in the form a minus b into a plus b. A square minus b square. So what is a square? A square is root 24 whole square minus b square is 25 minus x square root of 25 minus x square whole square by x minus 1 into root 24 plus x minus 1 into root 24 plus root of 25 minus x square. So I'll put square brackets here. Now this is 24. It is equal to, now it is equal to limit x tending to 1 of 24 minus 25 plus x square by root will go by x minus 1 into root 24 plus root of 25 minus x square. 25 minus x square. So now it is equal to limit x tending to 1 of, this is x square minus 1. X square minus 1. Again write x square minus 1 as x plus 1 into x minus 1. Root 25 minus x square here. Okay. Now write again when I substitute 1, 0 by 0 form only. So I am not substituting. Still I have to simplify. So I should write x plus 1, x minus 1 first. I'll write x minus 1 into x plus 1 by x minus 1 into root 24 plus root of 25 minus x square. So x minus 1 gets cancelled. Now you can substitute 1 and you can see it is limit x tending to 1 of x plus 1 by root of 24 plus root of 25 minus x square. Now when I substitute 1 here, I'll get 1 plus 1, that is 2. So it is equal to, I'll write there. So here I'll write. So it is equal to 1 plus 1 by root 24 plus again that is also root 24. 25 minus x square 1. 25 minus 1 is 24. So that is 2 by 2 times root 24. 2 and 2 gets cancelled. So it is equal to 1 by root 24. This is the answer. So it is equal to 1 by root 24. So whatever is asked, you simplify that. Limit extending to 1 of f of x. F of x is given. So write down. This is the solution. So f of x minus f of 1 by x minus 1. Simplify properly. Write the symbol, sign and all clearly. Then you can easily solve the problem. So after this it is here. Then it is there. 2 by 2 root 24. 2 gets cancelled. Okay. Now I'll give you homework. You can take down this homework. So with this, first exercise will be completed. So limit, first problem, homework. Limit x tending to 2 of x minus 2 by x cube minus 8. So the answer is 1 by 12. Now second problem, limit x tending to 3 of x cube minus 3x square by x square minus 5x plus 6. You can see it is indeterminate form. So must find factors and all. So you can easily do these problems. These are all example problems. So please try. So next problem, limit x tending to 3 of x cube minus 6x square plus 9x by x square minus 9. This is also indeterminate, but after simplification you will get, you can see when this is, when you substitute it is 9 minus 9 0. This is 27 minus 27 and then 0 by 0 form only. After cancelling you will get in the numerator 0, denominator you will get 6. 0 by 6 you will get. So 0 by 6 is 0. So like this you will get. You can try. Next is limit x tending to 2 of x tending to 2 of x square minus 5 by. So this is one problem. X square minus 5 by 4x plus 10. This is direct problem only. You will substitute and you will get the answer. Next, limit x. Okay, limit x tending to 1 of x plus 2 into 2x plus 1. 2x plus 1. The answer is 9. And then next is sixth problem. Limit x tending to 0 of x minus 1 by x square plus 4. So the answer is minus 1 by 4. Okay, now in the next period, so you have learnt two methods now. Factorization is one method and then rationalization is another method to solve when they are in the indeterminate form of 0 by 0. Now in the next period, we'll learn about the standard limits. We'll learn about standard limits and then how to find the limit using these standard limits. How to convert these limits into the standard form and then find the limit. So that part will be quite interesting. This is just a substitution simplification only. This is all very easy. Next part is very interesting, and you should write the steps properly. Limit extending to a. You see, you have, still we have time. Okay. Now see, suppose I say x is tending to 1. Then it means that x plus 3 tends to 1 plus 3. It is like equation. It is almost like equation where you can add the same number on both sides. You can subtract the same number on both sides. You can multiply with the same number. So 1 into 3. And you can divide also with a finite number. 1 by 3 like this. So this is one important thing. So x tends to 1 means you can add 3 any number on both sides. So it means that x plus 3 tends to 4. X plus 3 tends to 4. X minus 3 tends to minus 2. 3x tends to 3. X by 3 tends to 1 by 3. 1 by x. 1 by x tends to 1 by 1. 1 by x also tends to 1 like that. Okay. And there is one more thing. Wait. Suppose that you have x is equal to 1 by y. X tends to 0. So this means what? Y is equal to 1 by x. No. So x tends to 0 means x is 0. Almost 0. So y is 1 by 0. So y tends to infinity. Y tends to 1 by 0. That is infinity. So when you have like this, when x tends to 0, y tends to infinity. So these are some of the things which we need in the next other problems. Okay, we'll continue in the next one.